Okay, today we're going to work on a factor with a GCF and special cases. So when looking at problems, you always want to look for a whole problem GCF first. If there is one, you need to take out that GCF. So we'll work on those first. So this problem right here, I'm going to look at each term and I'm going to ask myself if there is a number or letter that go into all three of them. Well, for this one right here, there is a number that goes into all three. And if you're not sure, you can always use your Desmos calculator, type GCD with the numbers separated by commas, and you're good to go. So this one, a 3 is going to come out. If I take a 3 out, I'm left with x squared plus 7x minus 18. So then once you do that, you're going to now fill in our big X down here with, we're going to multiply 1 times negative 18. You get negative 18. 7 goes down here. The question is, what multiplies to 18 and adds to 7? And if you're not sure, you can use your Desmos calculator, type negative 18 divided by X, go down that list and find the two numbers that add to positive 7. And you should get 9 and negative 2. 9 times negative 2 is negative 18. 9 plus negative 2 is positive 7. Now we have our first term, and once you take that GCF out, keep in mind we're looking at this problem now. So we took that GCF out, and you have this trinomial here. And that's what you're using. You're using this trinomial here to do these two steps, your X and your box. So now that I've done that, I'm ready to fill in my box to do my factor by grouping. So I'm going to put x squared here, because remember you're using this one, not the original problem. We're done with the original problem. And then 9x is going to go here. Negative 2x is going to go here. Negative 18 is going to go here. Now, this is exactly what we did before, where I'm going to take my columns and my rows and take out the GCF. So from this row, I'm going to take out an x. This one, I'm going to take out a negative 2, an x here, and a 9 here. When you write your final answer, you will write x plus 9, x minus 2. However, when you take a GCF out, you must remember to put it in your final answer out front. So this is my final answer. Do not forget that GCF out front, or you will get a wrong answer on these. Okay, let's do our next one. So our next one here, I'm going to look at all three terms and say, do I have a GCF? I, in fact, do have a GCF. It is 2. I'm left with x squared plus 4x plus 3. I'm then going to multiply my a times my c, and I get 3 here and 4 here. What multiplies to 3 adds to 4? Well, that would be 3 and 1. Now I'm ready to find my solution. So the rest is the same as what we've been doing, so nothing new here. So I'm going to have x squared there. I'm going to have 3x there, 1x there, or just x, and then 3 there. I'm going to take an x out. Nothing comes out of this one, so it's a 1, an x out here, and a 3 out here. So your final answer is x plus 3 times x plus 1. But once again, don't forget, if you take a GCF out, it has to go in front of your answer. So that is your final answer. All right, I'm going to start you off on. All right, so this next problem has 2 typos in it. So I do apologize for that. It has 2 typos. This 2 should be a 4, and this should have a square on it. I don't know what I was thinking when I typed it, but anyway. So if you notice, we have our numbers are 5, 8, and negative 4. They do not have a number in common. However, they do have a k in common. but I need to take the smallest power of k, which is k squared. So what I'd like you to do right now is take a moment and tell me what's going to go right here. So I'm going to pause it right here, and you're going to tell me what goes on that line. All right, how'd you do? Did you get 5k squared plus 8k minus 4? If you got that, you did it right. All right, now we're ready to fill in our little x down here. I'm going to multiply 5 times negative 4. That gets me negative 20. And then I'm going to get 8 here. So my question is, what multiplies to negative 20? Adds to 8. I'll give you a moment to solve that. So, what I'm asking is, what number goes here and here? If you got 10 and negative 2, you got that one right. All right, I'm going to have you go ahead and finish this problem. Now, when you go to select the answer, be sure to remember to put k squared out front. K squared must be out front of your answer. So your answer better have k squared in the front and then 2 sets of parentheses. So go ahead and finish this problem on your own and see if you can select the correct answer. All right, how'd you do? Did you get k squared times k plus 2 times 5k minus 2? If you got that, you did it right. Good job. So that is the gist of the special case with the GCF. So each problem you want to ask yourself first, does it have a GCF? That is the first question you're going to ask. Now let's go to the second special case, a difference of squares. So when you do a difference of squares, here's what you're going to look for. A and B will always be perfect squares, and there will always be a subtraction. Remember, difference means subtraction. So two terms, subtraction in the middle, A and B, the coefficient of x squared, has to be a perfect square, and the B has to be a perfect square. So what are your perfect squares? Well, your perfect squares are 1 times 1 is 1, so 1 is a perfect square. 2 times 2 is 4. 4 is the perfect square. 9 is the perfect square. 16, 25, 36, 49, and so on. So if you want to write that list down, write that list down. It's a good list to have. There are more, so keep that in mind. You might have to do more later. So let's take a look at this. These are everybody's favorites. First of all, they're easy to recognize because there's only going to be 2 terms. There's always going to be a subtraction sign between them. And then the rest is just, can you fill it in? So your answer always looks like this. You're going to take the square root of this thing, which in this case is just x. And you're literally going to split it. I'm going to put an x here and an x here. I'm splitting the 2 x's. Then I'm going to split the 9 the same way. The square root of 9, is 3. So I'm splitting that number, 3 and 3. And then it's always plus in one, minus in the other. Every time. That never changes for difference of squares. So let's take a look at this one. 9 is a perfect square. 16 is a perfect square. So I'm going to start my parentheses here. The square root of 9 is 3. So that's going to go there. I'm going to split the y. The square root of 16 is 4. That's what goes here and here. And then it's always plus and minus. And it is as simple as that. You're going to do these last 2 here. So you're literally going to split them up. Give me 2 sets of parentheses with the answers. So your answer is going to look something like this. And we'll do both of them separately. So take a moment right now and solve that problem. How'd you do? Did you get 6m minus 11, 6m plus 11? Because the square root of 36 is 6. The square root of 121 is 11. That's where these come from. And then always a plus or minus. So give this last one a shot. This is the one everybody trips up on. But you have your list up here that helps you. Did you get x plus 1 times x minus 1? If you got that, you did it right. All right, let's go to our last example, our last set of examples. I only have 2 problems left. So the next one is called a perfect square trinomial. You're going to solve these just as we've been doing, but the answer is going to be written a little different, and that's the only difference here. So let's go ahead and do this. First, I'm going to look for a GCF. No GCF. I'm going to multiply my two terms and get 16. Put my middle one at the bottom. What multiplies to 16 and adds to 8? Did you get 4 and 4? If you got 4 and 4, you did it right. Now we're going to fill in our box over here. X squared, 4x, 4x, and 16, not 8. I don't know where I got 8 from. I got 8 from down there. And 16. You're then going to take out your terms, or I'm going to just do this one for you. And you get x on this one and 4 on this one. And then you get x on this one and 4 on this one. Notice they are identical. So when that happens, you will actually write your answer x plus 4 squared. So you're not going to write, you don't write it like this. We don't write it like this because it takes too long. Not that it takes that long, but it takes too long. So we are not going to write it like this. I want you to try this last one all on your own. There is no GCF, but remember you have to multiply these two to put it up top there. So make sure you do that step before you work on it. So finish that one, and that'll be all. How'd you do? Did you get 3x plus 1 squared? If you did it right. You're ready to complete the next assignment. Good luck, and let me know if you have questions.